Hello, everyone. My name is Tyler Rockmore. I'm a graduate student at Georgia Southern University pursuing my master's in music technology. And today I'm going to show you what I've been working on for the past month or so. This is my final project for a class that I'm taking called Sound Design and Processing with SuperCollider. SuperCollider is a program that is open source and it is a C-based synthesis language. Without getting too bogged down into the details of that, basically I can control any parameters that a synthesizer can control, but I can just code a synthesizer. So then the possibilities are pretty endless, but moving forward, I want to kind of show you what's going on with my code without getting too in the details. I have synthesis definitions for my microphone input. And then I have a synthesis definition for the vocoder algorithm, which processes the voice and separates my voice into different frequency ranges and will output based on what frequencies I give them. And I will show you how I do that in a second. But moving forward, I have a synthesis definition for reverb, pretty standard, and a synthesis definition for delay. And lastly, I have a synthesis definition for master volume. Going forward, I have my audio routing here. This is basically just how I send the audio to different places that I need it to send to. Down here, I have my effects, and this is where I actually play the effects. And right now, you might not be able to see it or hear the effect because it is running on a different bus than the actual output bus that you would hear. And I will explain why that is in a second. So going forward, this is the information that allows my MIDI controller to work. And this works with any MIDI controller. Some controllers have different knobs and things that I don't have. Currently, I only have a sustain pedal and the keyboard and a MIDI output. So I'm a little limited in that regard, but if you have a MIDI controller with different knobs, you can also use that as well, and you can start mapping different things to those knobs should you so choose. But moving forward, here is my application window. This is my graphical user interface for the vocoder. So as you can see, I have an array of sliders. I have 4 different sliders controlling different things. The first one being the wet or processed vocoded signal. So I can move that up and down if I want. This is my dry microphone signal, which you can't hear right now because it's not on, and we'll get to that in a second. And then I have my reverb slider. This is controls the send level of the reverb. And then I have the delay slider, which controls the send level of the delay, obviously. So I have a microphone button and a free all button. The microphone button just turns my microphone on. You can probably hear me a little bit differently now. And my free all button just is a reset everything. I just want to close everything, basically. So we're not going to use that today. But what I want to show you is that I can change the mix of the vocoded signal like this and say at its base level, this is what's going to output. Hello, my voice is now vocoded. I promise it's vocoded. It is definitely vocoded. So that is the general output of it. But the cool thing about this slider is that I can bring my voice up, the dry signal, up a little bit in the mix, so you can actually hear more of the articulation in the vocoded signal. Without that, if I turn that all the way down, vice versa, and turn the vocoder all the way up, you would barely be able to hear my voice, but you'd hear more of the actual process signal. So I'll show you. I'll turn this down, and I'll turn this up. You should be able to hear way more of the dry signal than the vocoded signal. And again, and again. And then vice versa, if I decide to bring up my vocoded signal and less of the mic signal, you're not going to be able to hear me as well, but you're going to be able to hear the vocoded signal better. Test, test, test. So the only issue with this is when you have your mic signal all the way down and you have your vocoded signal all the way up, you'll hear the processed sound more, but it won't be as articulate because a lot of the articulations get lost in the processing of your voice. So I always like to have my mic a little bit higher than my vocoded signal, just so I can hear the actual articulation and what I'm saying in the voice. Because without it, all you hear is the robot sound, and it can be very hard to distinguish what's actually going on. But moving forward, this is my send for my reverb, like I said before. And down here, these three knobs, I have my reverb controls. So I can turn up the mix. This is the wet and dry mix. So I can turn that up as much as I want. I usually like to keep it relative, not too high, because I don't want to hear only reverb. I just want to hear the reverb as an after effect. So with this second knob, this is the room size, which makes it sound like you're in a big hall or a big echo chamber or very acoustically sound room. And it will also trail the voice a little bit, and I'll show you what that means in a second. So I'm going to keep that all the way up so you can really tell the difference. And then the next knob is the damp knob. So this basically cuts off any high frequencies that reverberate. If it gets too much, sometimes when you have a lot going on with reverb, or when you have a lot of these levels sent, the high frequencies kind of cut up, not cut up, they actually become very present in the mix, and they sit a little where you don't really want them, so that kind of gets rid of those high frequencies. And just as a test, you should be able to hear the signal trailing off. You should hear the reverb kind of decaying very slowly over time. But conversely, if I did this the other way, test, you won't hear as much of that. So I generally like to keep the room size pretty big for this application just because I like the sound. But that is it for the reverb parameters. You can mess with those as much as you would like. And you can also mess with the amount of reverb you actually hear in the signal here. So that's one thing. But moving forward, I want to talk about the delay a little bit. So this is the same concept. I bring up the send level here. And then I can change the delay time parameter here. These are both delay parameters. Delay time being how much is the signal actually going to be delayed, and decay time meaning how long is it going to take for the delayed signal to finally decay and output nothing. So I will show you by putting the decay time down and putting the delay time up with the reverb. I could take off the reverb, and I'm actually going to do that. Test. You should hear the signal delayed by a little bit. And now I can put that delay time all the way up. Test. And you should hear that signal happening way later than previously. So my favorite setting, well, actually, before I get there, the decay time is going to allow me to control how long it's going to take for the actual delayed signal to decay. So if I put this all the way, maybe not all the way down, but pretty close to all the way down, and I do test, you should hear that signal start to trail off with the reverb. Actually, not with the reverb because I don't have it on, but you should be able to hear that signal kind of trail off and decay and decay. So it's like echo, 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 echo. It's how long it takes to decay. So now my favorite setting is actually turning both the reverb and delay on, maybe turning the damper up just to make sure we cut out most of the high frequencies that we don't want. And I like to keep the delay time a little bit down and the decay time all the way up. And this creates a really cool effect. Test. And that is my vocoder project that I've been working on. If you want, after you've done this, you can hit the free all button like that. And as you can see, the CPU power that it was using is just saying, or the CPU basically is cleared and the server is cleared. So there's nothing going on right now. So if I tried to do the same thing, it would not work. At least the reverb and the delay would not work. And that is my final project. I will post this in the description this source code. All you would need to make this work is SuperCollider, which is a free application and open source. Very nice. Then you will need a microphone with an audio interface. You can use your input from a laptop or from your computer. I wouldn't recommend this just because it doesn't give you the best sound, but it is definitely possible for you to do that. And then all you would need is a MIDI controller. And like I said before, if you have knobs on your MIDI controller, you can actually add things to this MIDI information to make these knobs correspond to what you're actually turning on your MIDI controller. So that is something in further development, but I will release those later. As far as that goes, that is my project, and I hope you all enjoyed this. And if you have any questions about how this works, or further questions about my code, or further questions in general, please don't feel like you can't comment in the comment section, and I will be happy to address any issues or any improvements that could be made to this. I hope you all enjoy this, and you all have a great day.